All right, we're going to continue on and discuss uses of molar mass. So we had been calculating molar mass in the previous lecture, and if you recall, the units on molar mass are grams per mole. So grams per mole. So when you calculate a molar mass, let's say, for instance, sodium chloride, the molar mass is 58.44 grams per mole. This molar mass can be used as a conversion factor. So you can use this written this way, or you can use it written this way, depending on what you need to convert. So if I had a starting quantity in grams, how could I convert it to moles using this molar mass? So let's say I have 58.44 grams. And using the molar mass of sodium, and this is grams of sodium chloride, using the molar mass of sodium chloride, I can convert it to moles. And I would use this one in order to get the units of grams to cancel out. And then I would end up with and it would actually be that. But we don't worry about significant figures in this course, so you're good. Okay, so if I had a starting quantity in moles, how would I convert that to grams? So let's say I have, I'm going to do this a little bit differently here. So let's do 2 moles of sodium chloride. And then I would use the molar mass conversion factor written like this. So it would be 58.44 grams over 1 mole. So then I would enter in my calculator 2 times 58.44. We get 116.88 grams of NaCl. Now, keep in mind that when you're using molar mass as a conversion factor, the number in grams always stay together. So they stay together all the time. So these stay together. Okay? So on the next page, we have some practice problems. So how many moles of each element are in 1 mole of the following compounds, and what is the molar mass? So I have several practice problems for you to work through, and it's good practice. Let's work through the first one, and then I want you to hit pause and work through them. Okay, so the number of moles, so 1 mole of iron 2-phosphate would have 3 moles of iron, 2 moles of phosphorus, 8 moles of oxygen. And then to calculate the molar mass, you're going to need to look up in your periodic table, first page or the inside cover of your textbook. So you have 3 times 55.85, that's iron, and then phosphorus, 2 times 32.06, and then oxygen, 8 times 16.000, parentheses, 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 add, equals, and you get 359.67 grams. So you can write the units grams or grams per mole. I really prefer to say grams per mole. It makes it so much easier when you're trying to work through a gram-mole conversion problem. Okay, so This next one, aluminum hydroxide, you have 1 mole of aluminum, 3 moles of oxygen, and 3 moles of hydrogen. So then you will have 26.98, that's aluminum, plus 3 times 16, plus 3 times 1.008 or 1.01. I am not picky. So when you add those together, 26.98 plus 3 times 16 plus, oops, not times, plus 3 times 1.01, you end up with 78.01. And again, I like grams per mole. Okay, so you're going to continue to do that for the next 5 problems. So it's a good idea to practice this on your own, because on the exam, you'll need to do this on your own. So I want you to hit pause, and then we'll work through the solutions when you come back. Okay, on number 3, there are 12 moles of carbon, 22 moles of hydrogen, and 11 moles of oxygen. The molar mass would be 12 times 12.01, 22 times 1.01, and then oxygen would be 11 times 16, giving you a molar mass of 342.34 grams per mole. For number 4, you have a bunch of carbons that it's kind of tricky to keep track of them, but it might be helpful if I highlight them so that you can tally them up. So you have 2 carbons and then 3 more. So 2 plus 3 gives you 5 moles of carbon, 10 moles of oxygen, 10 moles of hydrogen, excuse me. So you have 1, 4, 3 times 6, 6 plus 4 gives you 10, and then 2 moles of oxygen. And the molar mass is going to be 5 times 12.01, 10 times 1.01, and then oxygen would be 2 times 16, giving you a molar mass of 102.15 grams per mole. Number 5, again, it's kind of a cryptic way of writing a molecular formula, but it's still important nonetheless to understand that there is 1 carbon here and 4 carbons here, giving you 5 moles of carbon, and then 4 times 3, 12 moles of hydrogen. So you end up with 5 times 12.01, 12 times 1.01, add them together, and you get 72.17 grams per mole. All right, on the next page, let's see, lead to acetate, you have 1 mole of lead, 4 moles of carbon, 6 moles of hydrogen, 4 moles of oxygen. So lead, 207.19, carbon, 4 times 12.01, hydrogen, 6 times 1.01, oxygen, 4 times 16, and you get 325.29 grams per mole. And lastly, with manganese oxalate, you have 2 moles of manganese, 10 moles of carbon, 20 moles of oxygen. So manganese is 2 times 54.94, carbon 10 times 12.01, and then oxygen 20 times 16. You add those all together and you get 549.98 grams per mole. Okay, so we just went over how to determine how many moles are in something and then calculate the molar mass. Now what I'm going to ask you to do is to work gram to mole and mole to gram conversion problems. So with these types of problems, you will be provided with the molar mass. So you won't have to spend a lot of time calculating the molar mass as we did above. But it's still important to know how to calculate the molar mass. That will definitely be a question you're asked. But just not at the same time as you're asked to convert grams to moles or moles to grams, if that makes sense. Okay, so with this type of problem, you're going to be either asked how many moles of something or how many grams of something. So when you're asked how many moles, that means you would be given grams. So you write out your starting quantity over 1, and then you're going to use the molar mass as a conversion factor. And remember that this is really this. And depending on what conversion you need to carry out, you can flip this fraction. Okay? So for this problem, I have grams in the numerator. In order to get grams to cancel out, I need grams in the denominator. So I'm going to use this conversion factor right here. So 1 mole over 58.10 grams. My grams cancel out. And so 22 divided by 58.1, I end up with 0.378 grams. Or sorry, moles. All right, so the number that we're going to write down, 378, so 0.3787 moles. Okay, and then you're going to do the same thing for the rest of these problems. So let's work another problem. 0.587 grams over 1. I'm going to use this molar mass. Again, I can write it out in the fraction form. And I think when you're starting with these conversion problems, it's probably a great idea to do that. So I'm going to use this one. .587 divided by 95.21, and I end up with 0.00617 moles. Okay, so I want you to work questions 3, 4, and 5, setting it up on your own. Since you're given grams and you're asked to calculate moles, you're going to be working it almost exactly the way I have been, but the only difference is the molar mass and the starting quantity will be different. But this is your starting quantity, starting quantity, starting quantity, and then you're going to use this as your conversion factor. So it's good practice for you to do this on your own. So hit pause, work these, and then I'll have the solutions for you in just a moment. All right, so for number 3, you're going to take your starting quantity of 8.102 grams, divide that by the molar mass, 212.27 grams, and then your grams will cancel out. You'll be in units of moles, and so you'll get 0.03817. Remember, when you have something on the bottom, you're going to be dividing by that. So you enter this into your calculator, 8.102 divided by 212.27. Okay, for the next problem, your starting quantity is 44.409 grams divided by 342.30 grams, and then 1 mole. Grams cancel out, and you end up with 0.12974 moles. And lastly, converting copper to cyanide, so it's 82.10 grams divided by 115.59 grams. Grams cancel out, and you end up with 0.7103 moles. Okay, so you've learned how to go one way, from grams to moles. Now we're going to go from moles to grams. So you're going to write out the starting quantity, just like you did above, over 1, and then you're going to use this molar mass. So 241.88 grams over 1 mole. And it turns out that this conversion factor is written the right way. So you have 241.88 grams, 1 mole. So now my units are grams. So 0.1 times 241.88. So I end up with 24.188, so 24.2 grams. All right, let's do one more on this. So on the next page, you have more practice, which is, you can never get enough practice in chemistry. Practice, practice, practice. Okay, so we're going to use our starting quantity, and there's our molar mass. So 0.250 moles over 1 is 380.1 grams per mole. So you end up with 95.0 grams. Our moles cancel out. So one more time, I want you to hit pause and work these remaining 3 problems. Okay, so number 8, you're going to set this up in the same way that we've been doing these. Put the number of moles over 1 and then multiply by the molar mass, so you end up with 1.8 grams. For number 9, 0.335 moles is your starting quantity, so you put that over 1, and then you multiply that by 252.08 grams per mole, and you end up with 84.4 grams. And then lastly, you have 0.0548 moles over 1 multiplied by 399.88 grams per 1 mole. And then your moles cancel out and you get 21.9 grams. Now, what's important to consider is that on an exam, these will be mixed together. So you need to very quickly figure out what type of problem it is. And my advice is to write out your starting quantity over 1 and then look at your molar mass written both ways. Which way doesn't make sense? So depending on the type of problem you have, if you're really particular and picky and nitpicky with your units, you will always come up with the right answer. So practice these problems. We went over a lot of problems that you can practice, and you can never have too many practice problems in chemistry. You never have enough. So practice, 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 and I'll see you next time for our next lecture.